Let us begin with a new chapter that is called solid state chemistry. So we have studied in our previous classes that matter is mainly consists of the three things that is called solid, liquid and gases. So in this chapter we are going to study the entire the information what is going to belong to the solid we are going to study here. So before that we are going to start with the some of the characteristics of the solid. Let us discuss it here. So the first one, this figure says that the arrangement of the atoms in the solid, they are very closely packed with each other. I mean they are tightly with each other because there is no gap here. So they are very systematic arrangement will be there and they are closely packed system or they are very tightly with each other. Second property, second characteristic, it tells that they have definite shape, mass and volume. Yes, obviously you know that they will be having some definite shape, volume and their masses. Third property is very interesting. Internuclear distances are very short. What do you mean by internuclear distances? So if you take this atom, you know this atom is consists of the nucleus, right? So like this also we are going to take the center. So these are called the distance. This is called internuclear distances. So this is we are going to call as internuclear distances. Like this will be there. How they will be there? The internuclear distances are very short. They are very short. Why? Because why they are short? Because the atoms are very closely and tightly packed with each other, right? So the shortage of this intermolecular distance will be there. So next property, next characteristic, third one. Intermolecular forces are strong because they are due to this tightly with each other. What happens? The molecular force will be also very strong will be there. So it takes lot of time, lot of energy to break the atoms because of the intermolecular forces. They are incompressible. Yes, if you take the solid, can you compress here? Is it possible? Yes, it is not possible. So solids are always incompressible. Flexibility will be low because it has due to this solid state and intermolecular forces. What happens? The flexibility will be always very low. Next characteristic. Melting point and boiling points are very high. Why they are high? Because of the internuclear distance will be short, right? And their intermolecular forces are very strong because the coulombic force of attraction will be more. So it requires a lot of energy to break down. So that's why the melting point and boiling points are always high for the solid. Next, if you take the mercury, tungsten, how much? Because it requires more energy to break down these atoms because they are containing the melting point around 3000 degrees Celsius. Some of the metals will be there. The metals is nothing but the solids because of their internuclear forces. They are very high. Next, they are good conductors because they are the good conductor of the capacity. You can give the example as the copper is the best example, right? So they will be having the good conductors. Okay, this is about the very important characteristics or properties of the solid state. So in that you know that, so based on the closely packed system, solids can be classified into crystalline solids and amorphous solids. In crystalline solids, the arrangement of the particles, there will be the systematic arrangement will be there. Their order will be very nice. So that is in the three-dimensional space. We are going to cover as this crystalline solids are also anisotropic. We are going to cover as anisotropes. Why? Because anisotropy is nothing but if you take the some of the physical properties like mechanical strength, thermal conductivity, and also some of the electrical properties are will be depends upon their directions, right? When you think about this amorphous, when you see this structure, the amorphous solids will be having there will be not a good arrangement will be there. So because the particles will be not in systematic will be there. So that is called isotropic. Iso means same. Tropic means the same directions. The physical properties and some of the electrical properties, they are all be in the same directions. Study very deeply about these solids, crystalline solids and amorphous solids, and when you are going to differentiate between them. Let us study here a brief differentiation between the crystalline and amorphous. Here we are going to study in depth about these classification of the solid state. So let us discuss about the first one as a property that tells that shape. Yes, when you look at the picture of the crystalline solid state, how it will be there. So when you see this crystalline, so what happens? The arrangement of the constituent particles are in a systematic range. That is called very systematic range will be there, right? That is a disciplined mode will be there. So what about this amorphous structure? When you see this arrangement of the constituent particles, they are an irregular shape, right? So that is the crystalline having the geometrical shape. Geometrical or regular shape, you can tell this one. Regular shape you can see here. what about this amorphous? It is an irregular shape. It is an irregular shape will be there. So because of the arrangement of the constituent particles, how it will be there? If it is in systematic discipline mode, that is called crystalline solid. If it is not that is called indiscipline, that is called amorphous. So let us take one more property, that is melting point. Let us discuss about the melting point of these crystalline amorphous solids. So when you look at this crystalline, they will be having the sharp melting point will be there. They are very sharp melting point. And it is nothing but the melting point. What do you mean by melting point? Melting point is a point at which the solid states it starts to melt. That is called melting point. So here crystalline solids have the very sharp melting point. Why? Because of the regular pattern of the constituent particles. That is a disciplined mode of the arrangement of the particles. So that have the sharp melting points. What about these amorphous? They will be gradually softened. Gradually softened over the range of temperature. Over the range of the temperature. Why they are first they are melt soft very because of the irregular pattern of the constituent particles. I mean that is not indisciplined mode of the constituent particles. So that melting point comes to gradually so soften. First they become soften over the range of the temperature. If you take this crystalline melting point around 100 degrees Celsius, that is called sharp. But what of this may be vary 100 to 200 like this. Let us discuss one more property, that is called isotropic nature. It is called isotropic nature of this crystalline solids. We have seen the structure of the crystallines. So because they are called as the crystalline solids are called as anisotropic. So because of the systematic arrangement of the constituent particles, that is one parameter, and also why they are called anisotropic means, so when you look at the physical properties and electrical properties, they will be depends upon the different directions, right? That is called anisotropic. What are the amorphous? They will be isotropic. Iso means same directions will be there. Due to this irregular patterns of the constituent particles, they will be under the isotropic nature. They will be having the isotropic. Iso means same. They will be not depend. They will be the same directions. They will be the properties also in the same direction, like electrical properties or physical properties like mechanical strength, electrical resistance. They will be in the same directions. So this is about the isotropic nature of this crystalline solids and amorphous solids. So can you give the name 1, 2, 3? We have discussed the 3 points. So like this here 1, 2, 3. So next we are going to study for nature. What will be this nature of these crystalline solids and amorphous solids? So crystalline will be the true solids. They are the true solids, and amorphous will have the pseudo solids. Solids are also we are going to what is it? Supercooled. They are also called supercooled. What do you mean by this pseudo solids means? These type of properties which resembles the liquids. How means? So liquids, you know that there will be flowing will be the very fast will be there in the liquids. Like this also, these pseudo solids means they show the properties to flow. They also flow. So amorphous properties will be having the tendency to flow like liquids. Why? Because if you take the old buildings of the materials like doors and windows shapes, you can see there. So what happens? There will be a slightly thicker at the bottom will be more rather than at the top because of the supercooled. They are called as the supercooled or pseudo solids. Let us discuss about what is the arrangement of the order of the constituent particles in crystalline solids as well as the amorphous solids. That is called order of the arrangement. That we are going to call the order of the arrangement. How the constituent particles will be there? Because when you see the structure of the crystalline and amorphous solids, what happens? The constituent particles are in the repetition will be there. That is what systematic, regular, and periodic repetitions of the constituent particles over the entire crystals you can see here. That is in the crystalline. What about the amorphous? Amorphous, what happens? The regular and periodic repetitions of the constituent particles is observed over the only short distance. So So that is called the amorphous solids. I mean, we are going to tell the order like this. It is exhibit both long range. Usually, it is exhibit as a long range order. Also, sometimes short range order. But mainly, this amorphous is always the short range of the order. Short range of the order. Why? Because of this short range. Because of the reason that the constituent particles, the arrangement of the constituent particles in the amorphous solids, the repetitions will be observed but very short distance time. What about this crystallines? What happens? They will be always long range because of the systematic periodic repetitions is going to be observed entire the crystal system. That is called the arrangement of the order of the constituent particles.